these things it will be there. Okay, what is the meaning of a static analysis? In the static analysis, you know what happened? We are mainly, you know what happened? We are doing with the help of your problem. Okay, with the help of a cantilever beam. So the first and this is the question which is been given in your problem. So a cantilever beam. Okay, the cantilever beam. Consider a cantilever beam with the dimension of 4 meters. The length is having 4 meters, width is having 3.5 meters, and height is 3.5 meters. Young's modulus they are given 2.7 into 10 to the power of 10 to the power of 10 Pascal. Consider the following. The first one we are supposed to, first subdivision we are supposed to calculate the deformation of the beam. Second one we are supposed to calculate the what is the maximum bending stress along the beam. Third one we are supposed to calculate what is the bending moment. Okay, is it clear? The bending moment of the beam. Okay, is it clear? So these three subdivisions we are going to solve in this particular problem with respect to your cantilever beam. Okay, is it clear? So in this cantilever beam, you know what happened? It is being fixed at the one end. Now we are opening in a Ansys workbench software, selecting the static structural condition. We are double clicking on static structural condition. We are changing the program. We are changing the program name as a cantilever beam. Okay, is it clear? We are selecting into a cantilever beam, cantilever problem. Next one we are going for a geometrical engineering data. In that engineering data, we are selecting the material. Say for example, you can take any kind of a material. You can take a stainless steel, aluminum, or a cast iron. Everything you can select it. Next one, it is a isentropic process. We are selecting the, we are giving the value for your Young's modulus. Okay, in your problem, they are given as a Young's modulus. They are given 2.7 into 10 to the power of 10, and then Poisson ratio they are given in your problem. Okay, 0.0 they are given. The bulk modulus, everything it will be calculated on their own. Okay, is it clear? Next one we are selecting the units. Okay, is it clear? Next one we are selecting the units in the form of a mm or a centimeter or a millimeter. Okay, is it clear? Next one, after that we are closing it. We are going for a geometric analysis. Next one we are going to do the geometry. First one, for each and everything, the complete completion of the 7-step tick mark will be coming. Okay, is it clear? Next one we are selecting the geometrical. Okay, is it clear? Next one we are selecting the geometry. We are selecting once again. We are going to select the plane. What kind of a plane? Or sketching grid size XY plane. Look at the face. So that is the option for your look at your face. Sketching you are doing it. If you want to draw a cantilever beam, you are supposed to draw a cantilever beam. They are given the length. They are given the length value. They are given. Okay, is it clear? So after that, dimension they are given. What is the total length they are given in this particular problem? The height they are given as a 4 meter or a 3 meters, which is being given in your problem. Okay, is it clear? Next one, concept, line with the parts. Okay, is it clear? So apply. We are going to apply. Next option, it is your apply. Next one, it is your part design. We are going to select the part design. Okay, concept. The cross section rectangular. So cantilever beam, it is a rectangular. In this particular, you know what happened? They are given dimension. They are given what is the breadth, what is the height value. They are given. We are typing the value of what is the height, everything they are we are giving in this particular problem. Okay, please maintain silence, man. Next one, it is your line body. We are selecting the line body. We are selecting the rectangle. Okay, is it clear? We are selecting the rectangle, and then once if you are completing the geometry, means once again the tick mark will be there. Next one, we are creating the model. In that model, we are going to mesh the element. Okay, is it clear? Mesh the element. Next one, we are going to apply. Project apply. we are going to select mesh module. Sorry, module. In that module, we are going to select see extrude option. See cantilever beam, it has been there. Okay, next one, what we are going to select is your geometry mesh. Okay, meshing option, it has been there. We are selecting the steel and then mesh. In that mesh, there are two things are being there. One is being see after creating the mesh, see how many nodes and how many elements are being there. See 43 things are being there. 43 nodes are there. 21 elements are there. Okay, 43 nodes and 21 elements are there in your problem. And then analysis settings. Next one, fixed support. We have for cantilever beam, one end is being fixed. Okay, this end is being fixed. Apply. And next step, we are going to apply the load at the another end. Load force. We are going to select the force. After that, we are going to apply the load at the end of your section. Okay, at the end of your section. Say for example, see we are in this particular, this last one, we applied the load. We have to select the component. While you are selecting the component, you have to select a y component. The value must be minus. Why we are keeping minus means the load is being acting downward direction. Okay, is it clear? The load is being acting downward direction. Next one, we are going to do the solution, deformation, total deformation we have to select. Okay, total deformation you have to select. And then you know what happened, beam tool, beam tool, total deformation, and then generate or insert. Generate or insert, you have to do it. See, this is your normal, your total deformation of your material. Okay, is it clear? This is your normal total deformation of your material. See, you are clicking on the total deformation. The maximum deformation which is being takes place at the where the load is being acting. So that is the meaning of your what is the total deformation. Okay, is it clear? The first one we have selected. We have studied the Y max. That is a 3.79. Okay, is it clear? So 3. This is your what is the maximum deflection. So in this particular point where the red color is being there, that is the maximum deflection will be there. Okay, is it clear? That is a maximum deflection will be there. Next one. Beam. What is the maximum stress, minimum stress? Insert or evaluate. See, at the maximum things, your normal, your maximum bending stress will be takes place at the end. So this is the value which is being there. 3.36 megapascal it will be there. Okay, that is if you are taking means it will be there 3.36. That means the value what they are given in your problem, it is being correct, it is being evaluated. Is it clear? Next one, you say, take down the minimum.